In this first test 3 review video, we're going to go through some of the ideas from chapter 7 that you definitely need to be familiar with for your upcoming test. Jumping right in, you need to know the difference between statistics and parameters, and knowing examples of each will be helpful. We discussed this at the beginning of chapter 3. Recall that statistics are calculations from samples, and parameters are calculations from the population. So if I randomly select 100 students from TCC, ask their GPAs and find that average GPA, that mean GPA, that would be a statistic because it came from a sample of 100. If I'm somehow able to get data on every single student at TCC, the population, and I find the average of all of those GPAs, then I have a parameter. So statistics are calculations from samples, parameters are calculations from the population. You also need to be familiar with the components of the central limit theorem, how to test if these components are satisfied, and why the central limit theorem must be satisfied in order to proceed with our statistical studies. So first off, our components and how to test if they're satisfied. There were 4 components that we studied in chapter 7. There were 2 that we really focused on. Number 1, is it a random sample? And number 2, do you have at least 10 successes and failures? You could calculate your expected number of successes by saying N times P. N is your sample size, P is your population proportion. And your failure number, or your expected failure number, will be calculated as N times 1 minus P. If P is not available, sometimes we use our sample information, how many people were on the success side, how many people were on the failure side. As long as they're over 10, we can proceed. Now, there were other components that we didn't focus on. It would be helpful to know that we want independence between observations, and that if the sample is taken without replacement, that the population is at least 10 times the sample. These components must be satisfied in order for us to use a normal sampling distribution. A lot of our calculations require that the distribution be approximately normal, not skewed left or skewed right, so that's why it must be satisfied. Our next bullet point indicates that we need to calculate the sample proportion, that's p hat, and the margin of error when finding a confidence interval. Sample proportion, or p hat, can be found by taking your actual number of successes and dividing by N, the sample size. That's how that's calculated. The margin of error had a formula, and that formula will be given to you. It was a z critical value times the square root of p hat 1 minus p hat all over N. The z critical value up front will depend on your confidence level. If it's 95%, it's 1.96. P hat, we know how to calculate already. And N, that's just your sample size. We'll see an example of this in one of our future test review videos. The order of steps when finding a confidence interval by hand. Step 1, you want to find p hat. Step 2, you want to check the central limit theorem. Step 3, you want to find the margin of error. And the fourth and final step, the step we haven't discussed yet, is to take p hat minus E, your margin of error, and then p hat plus e. That gives you your confidence interval. You take your sample proportion, subtract your margin of error, your sample proportion, and you add the margin of error, and that gives you a range of values that we think the population proportion is somewhere in between. We're using our sample to make an assertion about the population. Once you have that confidence interval, you can interpret it. We always start with, we are blank percent confident. We're 90% confident. We're 95% confident. We have some degree of confidence that the population proportion of whatever we're discussing, college students who believe aliens have visited the planet, or teenagers who prefer bottled water, whatever we're discussing is between these two values in our confidence interval. We are blank percent confident that the population proportion of blank is between these two values. We've already discussed calculating the margin of error with a formula. There are alternative ways to do this. You can use your calculator. You can subtract the first value of your confidence interval and p hat. That will also give you the margin of error. And if you look back in one of our Chapter 7 YouTube videos, you'll see me do that. Going back to calculating a confidence interval with your calculator, recall that you go to Stat, Tests, and it's letter A, which is the 1 prop Z it. 1 prop Z it. You enter in X, which is your actual number of successes, N, which is your sample size, and then your C level, which is your confidence level, as a decimal. Final 2 bullet points are related. The effects of increasing or decreasing a confidence level on the margin of error and the confidence interval. To begin with, if you increase the confidence level, if you go from 90% confident to say 99% confident, that's going to make the margin of error larger. You're going to have more error, and it's going to make your confidence interval wider, which means you are less precise. So increasing the confidence level, while you are becoming more confident in your result, you're adding more error into your result, and your confidence interval is wider, and therefore it's less precise. Decreasing your confidence level would have the opposite effect. It would make your margin of error smaller, so there's less error, that's good. It would make your confidence interval narrower, so it's more precise. However, you're less confident in your results. So it's a trade-off when you adjust the confidence level. So we don't want to adjust the confidence level. The thing to do, if possible, is to adjust the sample size. If we have the opportunity, we always want to increase the sample size. By increasing the sample size, the margin of error E is smaller, and the confidence interval will be narrower or more precise. And we have the exact same level of confidence. We don't change the confidence level. We would leave it at 90% or 95% or 99%. But by increasing the sample size, we would get a smaller margin of error, and our confidence interval will be narrower. And we'll demonstrate this as well in our Chapter 7 example video for this test review.